All right, hi everyone. Is everyone ready for our lab today? Okay, that's good. So in this lab, we are actually building an MPPT to the PV array we built last week. The MPPT, the full name of MPPT is Maximum Power Point Tracker. So what this device do is it's always track the maximum power of the PV array or PV panel. Thing is, we still use the PV array we built last week. Oh no, 2 weeks ago. So use that model you have, and we're going to use a buck converter with a load to uh to kind of realize the maximum power point tracker function. So in this lab, two things need to build. One is this buck converter, and the second one is the MPPT algorithm, like built it in the PWM generator. I assume all of you know how buck converter work. So how about firstly we build our buck converter together. If you haven't started your lab, build your buck converter now. And any problem happen, we can fix it now. Okay. So my expectation is in this lab time, we will finish this step one together because this is most important. And I'll help you to build this signal builder for your irradiance changing. And if you can't finish all the steps, that's fine because step three only needs to change one of the signal builder for one PV panel. So if we can finish step one and finish this signal builder, we win, okay? So everyone just start to build your buck converter now and tell me what problem you have, and we can like fix the problem together. While you are doing your buck converter, I've already received some questions of this model. Okay, so the first thing is you can't figure out this part and this part. So this thing, the first thing, this little bar called, oh, I hate this bar. How can I move it? Okay, yeah. This thing called D, I guess, D what? Boss selector, really? Dmax, I think it's Dmax. Yeah, but boss selector, it looks more like a boss selector. Let me check. Okay, yeah, it is a boss selector. So this thing is boss selector. You can find it in your block library. And this thing is a go-to tag. So just search go-to tag, no go-to. And you will find the go-to, which means the things you are receiving, and to where is using from. So like here you use VIPV, and this value is using right here. So this is a pair of go-to tag. Another thing is this bus selector is selecting the signal that's given, like it's like a filter that filters the signal you want. So for now, it's like this measurement gave you all these 5 value, and we only want the VPV and IPV, so we just click it and select it to the right hand side. This means you only need the VPV and IPV. So, okay, this is another question. I think it's you asked, or yeah, another student also asked this question too. So you can just, for diode, you can use the diode, whatever it has, but the thing that in the PV array that it doesn't have a little resistor there means it's a totally ideal resistor. So if you want to set the diode looks like that, you can use the value I provided here. And for this diode, I think I only just like pull out the diode, so I didn't change any parameter inside this diode. So I just use the diode it gives. Okay. All right, so this is the answer for the diode. Let's move on to this capacitor. So for this is a DC link that it can stable the input of the MPPT. Usually buck converter don't have a capacitor here. So this resistance is only like the resistance of a capacitor. So it's really small, it's only 0.1, and the capacitance is 100 millifarad. So this is only used for like make the oscillate of the input voltage stable that can make our this MPPT work. Okay, so just use this value. Another thing, oh, this MOSFET is also, I just pull out. I guess I just pull out the MOSFET. So I didn't change any value inside. Oh God, another question is how to like program your MPPT. So for program MPPT, this thing called Matlab Function, you can find in your Simulink library, like function. Here, Matlab Function. So just drag this onto your campus and it will show up here. And the thing is, you can use this as Matlab function as when we code it in Matlab. So to code it inside it, you double click it and it will show like this. To make your input, be two, like VPV and IPV, you change the input here. So the variable here is the input variable. So if you have two, then you have got two inputs. If you have three, then you got three inputs. And this is the MPPT. We are going to code it by using this flowchart. Okay, so try to do your version first and see if it can work. And we'll help you, and I'll help you if you cannot make this work, because this is quite important. This is almost like the key of this lab.
Excuse me. I have the question.
Yeah.
Can I just share my screen? Can you see my circuit?
Yeah.
So when I just wrong, it happened error. Can you see the error?
I can't see the error.
Oh, sorry. I will do another. Can you see my arrow?
Okay, I can see that. Okay, so you continues. Okay. So how about I'll give you a few solutions and you'll try that and we'll see if that can solve your problem. Okay.
Okay. So when I just double click, it just
No. That's not this problem. So
okay.
go back to so at the right bottom of your window, you got a OD23 TB.
Here.
Yeah, that's right. Click that and click the little gear. Click the little gear over there.
Yeah.
So can you find the solver for ODS 23S? The solver.
ODE
Yeah,
23.
the ODE 23S.
This one?
Yeah, that's one. Yeah. And apply it.
Right, okay. Wrong.
Try it.
I think that should be work. I will check the scope.
Okay, so check the scope.
Is that correct?
So do you have a scope for your duty cycle?
Yeah.
Can you show me your duty?
I'm not sure which line is the duty.
Okay, so give me a duty, like what's your duty change? That will be clear.
Okay, I will make a new scope.
Yeah, make a new scope for your duty. Okay. Where's my window? Okay, so I got a question that he can't find those two things. And I find the thing is happening here. You just like you don't need those things. You just use your tag and connect the tag to the scope and everything can work. Just don't use all those things. You don't need all those things. We only need the signal. So use the signal, that's it. So that is only for like select the data type, everything. So you don't need to do that. Uh, 0.65 is too much. I think let me say it's like around 0.45. So if everyone wants to know what's the result for our task one, this is the result I did for this PV array. It can be slightly different because you are using, I guess, if you choose different parameters or your duty increment, you choose like a little bit larger or a little bit smaller increment, it can be a little bit different, but overall the result looks like that. So the first question is, how do you make the P&O function has two inputs? I just said when you double click it, you will like coding this function, and by coding this function, the input of this function is defined here. So if you want two inputs, you make VPV and comma IPV. This means you have two input of your function. Okay, so I'll answer this question. If that's a MOSFET, what's the setting? Yeah, this is a MOSFET. So just search MOSFET, and I didn't change any parameters inside this MOSFET. So I just directly use it. So don't worry if you need to change any setting.
Hi, can you hear me?
Yeah.
Maybe my internet is not very stable. So
okay, so can you click the scale so that the scale to make the like every waveform to like wholly show in this.
Do you mean the duty cycle graph?
Yeah, so first select the duty cycle graph. Then just click your duty. Okay. Click your duty
I'll zoom out.
then
I'll zoom out for you.
no, I need, so firstly zoom in. I want to see your whole 4.5 second. What happened in your? Okay. So this is for task 3.
Yes, this is for task 3.
So task 1 you are already done.
Yes, yes. This model works for task 1 and the task 2.
So for task, so this is your
task 3. And the
okay,
duty
task
cycle
2
for
is
task 1 and task 2 are also 0.65, which is different from your 0.5. Yes.
Okay, so let's go back to your task 1. Okay.
Task 1, I need to change my irradiance to 1000.
Yeah. I can see that. Then just change it to 1000 and show me your result.
Okay, I'll change it now.
Yeah.
Can you see all the graphs?
Okay. Yeah, I can see your duty. The
duty is the same.
Not correct.
Not correct.
Yeah.
But
yeah.
Another graphs are right.
The power is right.
Yeah. And
okay.
the VPB IPV is right.
It's also right.
And yeah.
Okay, I know the problem. So can you show me the resistance of the what's the resistance you choose?
There are 2 resistors.
Yeah, not that one, the output one, the load one. The second one. Yeah, that's right.
I choose 20 ohms.
Okay, so that's why so just keep your 21 and my one is 10, so that caused the difference. So yeah, your answer is right. And so your task 2 is also giving you, so let's move to your task 2. Okay, so when you connect your change irradiance to the PV panel, show me your duty changing. And if the second one is all good, then we'll move to the third one. Okay. Your first one is totally right.
Yes, I think the duty cycle will not change.
The second one? The second one, the duty cycle will change.
Will change? Oh.
Yes.
I'll try now.
Okay. Okay, while you are trying the task 2, I'm answering other students' question, and when you finish everything, you share your screen and we will solve your problem later, okay?
Okay, thank you.
I got the duty cycle for around 0.4. This is depend on the load you are choosing. So if your load is same as me, I choose a 10 ohm load, then 0.4 is good. If the right or wrong only depend on the power you got. If the power is the maximum power, then that's good. The next question is why I have 4 points on the MOSFET. I have an extra M point. Really? Okay. Okay, that's fine. The endpoint is measuring, so just do not connect anything, then it will not work. It will give you warning, but if you don't want the warning pop out, you can search terminal and connect a terminal at the end of the endpoint. Then that will not give you any error from that block. May I have a look at the diodes and irradiance. Okay, share my screen. So, use whatever the diode setting as your first lab. And for this lab, this diode, I think I didn't change any parameters inside this. So, right, I think this is what it is when you drag this block out. And what's the question? And the irradiance. Okay. The irradiance. So for the task 1, the irradiance is only 1,000. The parameter. This is not IGBT. This is a MOSFET. So again, I didn't change any parameter inside this. Use MOSFET instead of. Well, I guess yes, you can use IGBT, but yeah, I use MOSFET. Okay, now we've spent like almost 40 minutes on our buck converter. And I'll like push you guys forward. So the next, which is also the very hard part, is you need to code your MPPT. So by doing this in your lab notes, you have a flow chart. So I encourage you to use this flow chart to code your MPPT. And I'll show you the main part of this, like sort of how to do this, but you will figure out like other points, like how to make this really work. Like how to say that? Like I'll show you like the bone of this program, but you will have to know how to make this work. If you only have this part, you will not make this function work. So that's why you need to figure out how to limit the duty cycle. The duty cycle is from 0 to 1. So not only you need this part, this is like what I said is a core part. You also need to consider a lot of questions like what you said is the duty cycle can go negative. You can't let it go to negative, or you can't let it go to like more than 1. What mean another result? You mean your task 1 is right, but task 2 and 3 is not right? So that's that can be because your task 1 is like simplest situation. Your irradiance is like stayed at 1,000, and when your irradiance change, your duty will change. So that may cause problem. I can give you a suggestion that you make your duty start at almost 1, like 0.9 or 0.95. So this means your MPP scan from the output voltage. What I mean is you make your duty scan from this side rather than using this side. So it's scanned from here to find your maximum power point. That will avoid that it cannot find anything and goes to negative.
Okay, I didn't open my microphone.
Okay. So what's the question?
Just a minute. Where's my graph? Okay, can you see the graph?
Yeah, I can see that.
Yes, I think, and you can see the graphs. I think the VI and P, they are all right. You can see the PPV. It changed with the
As your
irradiance.
irradiance change, yes, that's right.
Yes, and the power, the P out is always equal to the
P out
P.
doesn't matter. So if PPV is right, then you are right.
Yeah, yeah, PPV is right. The curve is right. Seems right.
Yes.
And you can see the duty cycle here.
Mm-hmm.
The duty cycle, they will change with the change of the irradiance.
Yeah, it is right. It will change.
Yeah, it seems right too. And as you can see, at the very beginning, it will go to negative.
Even if
yeah,
okay.
only at the very beginning it was wrong. But you can see at 2 seconds or 3 seconds, they are all right. The data.
And so,
all right.
can I say your irradiance?
Okay.
Your irradiance just follow the signal builder.
Signal builder.
Yeah.
Can you see it?
Yeah. That's okay. Okay, go back to your duty. I guess there's some problem in your MPPT. So for it's true, like when the let me see, it's like less than 1.5. Okay. It's true when less than 1.5, the duty will be very small, but it cannot be 0. My suggestion is you first add a limit that not allowed your duty to go to negative. And let me see. Yeah, see if you can let, you need like limit. You need a duty max and duty minimum to like fix your range of duty. Try to do that first and see if it can work. And the second thing I can suggest is that what I said is like track the when you coding it, you are actually like changing the duty from one side to another side, right? So change from the bigger number like 0.9, 0.95, and make it like smaller, go back to the, like, for example, when the true duty is 0.6, so you track from 0.9 to 0.6 rather than from 0 to 0.6. Did you understand what I said?
Yes, I see. But another question I want to ask is the PPV and P out and all other graphs are right, but only the duty cycle.
No, see, your PPV is also not right. So
not right. But
yeah,
but
so,
I think for the task 1 and task 2, the PPV is right because the power is around 59. Yeah, the max power is around 59. I think it is correct.
Okay, so this is for your task 2, right? Or task 3?
Yes, task 2. Yeah, as you can see the here, the 2 seconds. No, not 2 seconds. The 1 point. As you can see, the 2 seconds, the irradiance is 1100, so the PVV is around 60. I think the number is right.
So this only means that when your irradiance is over 1,000, this is right. but now your MPPT doesn't work when your irradiance is at 200, 400, and 600. That's the problem. Like your MPPT doesn't work when the time is less than 1 second, but actually it can give you power.
Less than 1 second.
So, okay, so stop your sharing. I'll give you the right graph and then you will understand what I'm talking. I still doesn't like finish the whole the whole graph, but you can see that like lower than 1.5, where is my power? Okay, let me see. So this is my power. So see, when the time is less than 1.5, I still got power like output from my PV array. Just forget about this value because we are using different load. So my load might, my duty waveform might be totally different from yours, but the power should also, like we should also get the power at this side. So when you get your 60 watts output, this is only mean that at the like 1,000. Okay, I'll open. This is only mean like when your irradiance is here, you get the you catch the maximum power, but you didn't catch the maximum power at this side. So that's why I said it's your coding problem. And this probably is because you are like searching the maximum power point from this side. So that's why I suggest you to search from this side and to go get the maximum power.
Okay, got it.
Yeah.
Okay, I will check the code.
Okay, we spent like an hour in building the upper circuit, and now we are going to build the irradiance together. So the irradiance changing, the waveform for irradiance, we are going to use a signal builder. Search signal builder and drag this into your canvas. The value is for task 2. For task 2, the value you are using is in table 1. So let's to make the irradiance same as this table provided. There are 2 ways to do that. One is you can import this data into the signal builder, but that will be a little bit complex. So now I'll let you know the most stupid way to do that. So when you open it, if you want to add a signal point, just click Shift and you can add and click the line you can add on the point. And if you want edit the point, you will put like here is 0.5 and the value is 100. And then you can like edit this point. Same you can do to 0.7, it's 200. Things like that. And if you want to change the timeline, you do at the axis change the time, and you can change this to 4. And it goes to 0 to 4, 4 seconds. And again, if you want to add the point on, you just hold Shift and then click on the click on the line, and you can get you can add on the point. All right. Is that clear? Do you have any questions? What is the period? You mean the time? So because the task 2 and task 3 ask you to do the simulation for 4 seconds, so that's why I changed the time scale to 4 seconds. Okay, so sorry about that. So when you calculate your duty, you still need to make your duty to PWM pulse. So that's why we need this PWM generator. So be careful use this PWM generator DC to DC because there's a lot of PWM generator, and the frequency does really not matter. You can choose 30 kilohertz, 40 kilohertz, or 50 kilohertz. The only thing is make it like 30 to 50 kilohertz. Well, that can be a big problem, so I'll search this to show you. So see, there's a lot of PWM generator, but you use this one, PWM generator DC to DC, okay? Can you explain the stamina equivalent of the buck-up method equals to the load impedance? This equation is in your lab notes. Which equation you want? You want me to explain this one?
Hello, can you hear me?
Yeah.
Okay. It says it, so if you go up a little bit,
Okay.
just scroll up in that paragraph there of the buck converter. It says it in the first sentence, and I was just wondering what that meant.
Sorry, I lost you.
The first sentence, yeah.
According to the maximum power, the power output of circuit maximum when the seven impedance of the circuit. I guess because we usually don't calculate the seven impedance of the PV panel, but I guess the question here is this seven impedance is this R in, so this R in is R in equals to V in divided on V I in, and the load impedance is V out divided on I out. Yeah.
Yeah, because I'm trying to build the codes for the duty cycle. I was just trying to find something in there, you know.
You can do that. Yeah, you can do that.
Thank you.
Okay. The next question is so slow for the simulation. 1 minute for just 3%. If it's very slow, you can try to do one thing is by click the very right bottom of your Simulink here. It can be anything here. I don't know what's happened in yours. Click here and change your solver to ODE 23S. This will improve your speed. How to get VPV and IPV? I only use the right hand side for the. Okay, so if you only use this side, it's easier. So the bus selector is select the signal you want to use. So by select VPV and IPV, you only click select, and don't click this little box. Let it out. Okay, and then you have two output. So one is your VPV, another one is your IPV. Okay. Or another more stupid one is you only select one. Let me see. You select one, this is your VPV, and you click OK, and the output is VPV, and you use another one to do your IPV. Like you use another one and only select IPV here. Sorry, how to add as a tool, just have to input. Okay, again, you can make it by double click it. It has a list of sign. If you only have 2, you add a plus, and you will have 3 inputs. How to define the output in the code? So if you want to define the output, I guess it's like what's your this part, what's your this part in your function. In your function, you just make like this is for duty, like duty equals to this is your function name. This 2 is your input. This is not a big problem. Okay, so this is because I guess you're not using selector, or the selector setup is not right. So set up your selector. Okay. Return. So by returning it, that means the function you're using is here, like something equals to, this is your input, this is your output. So this D is your output of your output of your function. I guess this graph is your duty cycle. If your duty cycle is this small, then that's not right. And I can see that you trace the maximum power from when duty is 0. So I suggest that you track your duty from I will not say 1, because 1 is when input is equal to output, that cannot be reached. So I'll say 0.9 or 0.95. I don't know the structure. The structure, okay, so if you don't know how to code Matlab function, you can use help. So inside this, you will see how to like code it. All right, it's the end of our lab. So I am recording this lab, so I'll have a little bit editing of this video to make the empty part, like I will cut out the empty part so that makes the video so that can save your time, and I'll give you the link later. So that's it. That's all about our lab today. Well, thank you for your coming. I'll end up the meeting.